My name is Alberto Brignone, and I am co-owner and director of two companies, citiEU and citiME. I will basically be in charge of a little bit of I will manage the meeting, but the real presentations will be provided by my colleagues Luigi and Antonio. Just a quick introduction about this webinar and the scope of the webinar. Basically, what we do as companies are, we are experts in transport modeling and planning, and we've been working for years with software for transport planning and modeling, and in particular with the 𝗘𝗲𝗃 platform that is now developed by Bentley Systems International. And we have also long-standing partnership with TomTom as providers of big data. And our goal has always been to try to implement solutions that can combine the two of them. So combine big data, all the data that comes from different sources in terms of transport modeling and our models. I have more than 20 years experience in this field, and when I was a young engineer, basically I always struggled in finding good data, and there was always a it was extremely difficult to get relevant information, good information. Nowadays, we have easy access to different solutions, and so we decided to share our experience and to show you some of these products. So to give ideas, to provide ideas, and to show you how we use this type of information, and then stimulate a little bit of the conversation as well. Apart from me, as I said, Luigi and Antonio will be actually the main presenters of this at this event. Luigi will focus on showing a couple of products from TomTom that are the OD metrics and the TomTom Multinet and speed profiles, and how we use them in transport models. Antonio will also discuss and explain how we use TomTom OD metrics with metrics estimation procedures, and how we use speed profiles and other data coming from TomTom datasets with transport models. It's an impressive number of attendants, and of course we can't have a live session of question and answers, but everybody can type in the chat area questions, any type of questions you have. And if not today, because of during the seminar itself, in the next few days we promise we will reply to all of you with all the questions that you raise, so to be sure that you are that we can provide you all the information you need. Next slide, Luigi, please. Just a very quick background about the three of us. As I said, I am the director of the company. It's kind of shocking, 24 years of experience. I always think I'm a young professional, but I'm not. And as I said, I'm director of these two companies, citiEU, citiME. I will tell you briefly about the companies in a few seconds. Together with me, we have Luigi, who is a senior engineer, PhD, and is our expert in traffic as traffic data analyst. And we have Antonio Restuccia, who is an experienced senior engineer, experienced transport modeler. We all have experiences in the use of data and then the development of models in Italy, but I would say mainly abroad. Luigi, next slide, please. So two words really on the companies, citiEU and citiME, sister companies based in London and in Abu Dhabi. The companies are managed by 𝗕𝗏𝗃 and by me. 𝗕𝗏 is based in Norway. The operations, so our operative office is based in Italy, in Milano. That's where we are now, basically. We actually are not only consultants in the field of development of transport models, but we also offer and sell software and technological solutions. We are channel partners with Bentley Systems. We are resellers of TomToms, and we are resellers of IntuVision video analytics. We do models, we build models, we do consultancy, we do training, and we are official trainers for 𝗬𝗏 and Legion. Now we move to the core of the presentations. Again, for the ones who have been admitted just recently, please be aware that we are recording the presentation. And yes, the recording of the presentation will be made available at the end of the event. Luigi, I leave the ground to your presentation, so please go ahead.
Thank you, Alberto. Before talking about using TomTom with transport big data, I would like to show you what is TomTom floating car data. The first source is TomTom data as a smartphone. For example, Apple Maps use TomTom Maps, so all iPhone are TomTom devices. Other apps are, for instance, Amigo by TomTom, or other websites that use TomTom Maps. Another data source comes from the automotive world. Car manufacturers such as Nissan, Renault, Volkswagen, Stellantis have integrated TomTom Maps. Other source is TomTom logistic device. Other traffic data comes from detector loops and the camera installed on the road network. Now I would like to take you a quick look at two pictures showing TomTom device operating in two major cities, Berlin and Paris. TomTom is not only a navigation hardware company, but has also become a major supplier of traffic data. TomTom major big data products are related to maps, navigation for automotive, and road analytics. Today, we will look at the main tools supporting traffic models. That means Multinet maps, speed profile, and the TomTom Move portal. TomTom makes access to its transport big data through Move3 portal. On the portal, there are 4 modules, 2 related to real-time and 2 related to historical data. The use of the portal is user-friendly and very fast. In a few minutes, you can create mobility analysis around the world. Analysis can be created on the full TomTom coverage, which means most of the globe, Europe, North America, and countries in Asia, Africa, and South America. This is the first module. Route monitoring is a module of the TomTom portal that allows analyzing a route in real time. Real time means having fresh data every 60 seconds. Route monitoring makes it possible to observe congestion level on a route through travel time, speed, and length. For example, this information can be linked to a variable message sign to inform user of any inconvenience within a route or road, like an accident or road work and so on. This information can also be sent via API to a server that manages it and create alerts. This is a very flexible solution. Junction Analytics is a module of TomTom portal that allows the real-time analysis of a single junction, or in this case, a group of junctions, which means like a micro-simulation model. Junction Analytics provides valuable information to transport planner or public bodies, such as current and free flow travel time, delay, level of service, volume per hour, turn ratio, and queue length. This information can also be sent via API and can be used to import for a traffic model. Other applications can be the designing, optimizing, and monitoring of a traffic light system or for our mobility plans. Traffic Stats is a module of the TomTom portal that allows analyzing the speed on route or networks for a given time range, for example, 1 or more days, and for a set time, 50 minutes or an hour. The data shown on the portal can also be downloaded in a shape file and then analyzed with the GIS software. One use of traffic stats is for pre and post event analysis. The picture shows the impact of a reduction from 2 lanes to 1 lane of a major bridge in Palermo, Italy. The links in red indicate a reduction in speed compared to the typical speed at that time. For example, in the selected link, there was an average speed of 2 km/h, and the typical average speed is 40 km/h. The image shows that there was a reduction in speed all over the city. This comparison of 2 reports is, in 2 different periods can be made for various reasons, such as quantify or monitoring a mobility plan action, quantify the impact of an accident or road works and or any event altering the normal mobility within a network. These reports can also validate traffic models or create accessibility maps. We plan future webinars on these topics. OD analysis is a module of the TomTom portal that allows building origin-destination matrix. The traditional analysis examines a relationship between macro areas, which can be the boundaries of the municipality. This information can be used in a transport model in the calibration or the validation phase. Antonio will explain how later. The TomTom portal provides outputs, not only the matrix in Excel format, but also other graphical outputs. In this slide, we see an automatically generated output from the portal, the side line between regions. This is a comparison between EM peak hour and PM peak hour. The portal offers the possibility to select individual region for sub-analysis. In this case, I have selected for external centroid that identify the motorways to Genoa, Italy. Other outputs are the flow distribution during the day. This other 2 diagram show the trip length distribution in terms of route length in kilometers and route duration in minutes. Here is an overview of the possible applications of the OD analysis. I have already introduced the big area. Path analysis. I have drawn 2 polygons, the east side and west side of Rome, and selected all the bridges between the 2 regions. The feature allows me to rank the most used bridges and draw up a vulnerability analysis. What happened to the mobility if I shut down one of the bridges? The selected link here is a new feature in TomTom and allows me to analyze a section of a road, both outgoing and incoming, and I can analyze the path distribution. Finally, I can also analyze a traffic generator such as a stadium, shopping center, airports. In this example, I analyzed a university campus. In this analysis, allow me to answer where do the user come from and at what time do they access the area. TomTom data can be used for accident analysis models. In this study, I have used the traffic stats and the OD analysis modules to analyze an accident on a motorway in Northern Italy. The animation shows exactly what's happened. In the traffic stats, see the speed and the congestion level each 15 minutes. With the select link feature, we can understand and quantify how users behave in case of accident. Do they stay on the motorway or look for an alternative route? And which alternative routes? With the TomTom portal, it's easy to make this analysis. citiEU has been a reseller of TomTom traffic data since 2012 and can provide you with a free demo account to evaluate all these features. So if you are interested, can you contact me by email? Now I will speak about TomTom's Multinet map. They cover more than 100 countries and have a length of 35 million kilometers worldwide, almost the distance of Venus from Earth. Network attributes can help in the construction of the transport models. For example, functional road class, form of way, speed category, free flow speed, speed profile. We have built a process to convert and optimize TomTom Multinet for transport models. An important step in the conversion process is consolidation. This means that very small but sequential links with the similar feature are transformed into a single link that maintains the shape and the attributes, but without all the intermediate nodes. For example, stretch of motorway, which in TomTom are broken into many links, for us become one single link having the same functional road class, same speed, same name, and many other common attributes. This process makes the network much more manageable. The network resulting from this process is an attribute-rich network with high accuracy in the description of one-way street and prohibited terms database. This means significant saving in process time and network preparation. In just a few hours, the road model is ready. Next slide, please. The speed profile modules had speed information to the Multinet network, which means free flow speed, weekend speed, weekday speed, and speed profile for each day. These profiles are representative of the average speed variation along with a network link for a time interval of 5 minutes over 24 hours. Each link is associated with a specific speed profile for each day of the week. In this chart, you can see 293 profiles. Next slide, please. In this example, we see the network near our office in Italy. I have highlighted 5 links in different colors and represent roads with different characteristics. Yellow and blue are in the motorway, green and purple are in the primary road, and red is local road. Even though they are very close to each other, these 5 links have very different speed distribution. Next slide. This diagram shows the speed profile of the 5 links during a typical Wednesday. On the x-axis, we see the time of day, and y-axis, the speed in kilometers per hour. From the diagram, we can see that the speed profiles are very different, even though the yellow and blue links are very close. Even the profile are different. If we look at the yellow profile and the red profile, the speed are completely different. This is a quick overview of the tools available to extract big data. Next slide. Before handing over to Antonio, one last thing. We have created a new LinkedIn group called the Transport Big Data, where it's possible to share experience on the use of traffic big data in the transport world here. We hope you will join to the group. Thank you. Alberto.
Thank you, Luigi. There are a lot of questions popping up in the chat group. I'm not ignoring them, but there are too many and I can't type quick enough. So I promise we will answer to all of them, and we will prepare a question and answer sheet that we will send to all the participants. There is another question that came about having a certificate for the seminar. Well, we were not planning to do so, but if someone needs this for any reason, just send us an email and we will provide a certificate for participating, for being here. But it's not going to be kind of a default thing that we will send to everybody. So I will now let Antonio take the lead of the conversation, and we will discuss a little bit about how using some specific data type for our modeling efforts. Please, Antonio.
Thank you, Alberto. Let's start with a sentence, with a famous quote. Essentially, all models are wrong, but some are useful. What do we mean with this? Travel models are a closed system distinguished by mathematical formulas and relationships, and these models are used in an attempt to reflect an open system, the real world. Now, since travel models and travel modelers cannot be omniscient, there will be always some missed information and abstraction, resulting in less than perfect models. TomTom, Multinet, or the analysis and speed profiles, all the tools that Luigi has shown us earlier, they represent a valid support to model calibration and validation. So, in order to answer the second part of the quote, the usefulness of the models. Just a quick recap on what is calibration and validation. So calibration is when we adjust constant and other model parameters in an effort to make the model replicate observed data, usually for a base year, or otherwise to produce more reasonable results. Whereas validation is the application of the calibrated models and comparisons of the results against observed data. Sometimes these two words are used as interchange, but they have two completely different meanings. And usually we tend to use different data to calibrate and validate. The two processes are separated. Now, Multinet and transport models, they provide a good description of the networks, as Luigi said, with a network regularly updated every 3 months. and high precision in the description of one-way streets and bound turning movements. In this picture, you can see the turning penalties of in Cairo. So all this information, all this quality information can provide great time saving when you prepare your road supply model. It's also easy to link this information with the General Transit Feed Specification data, so the GTFS for public transport. All these will result in a minimization of the human error when coding. So Cube can be used in combined processes, and it's able to give you a high flexibility in the management of complex database. It's possible to integrate Python and GIS. For example, the picture on the right shows an application that allows to convert GTFS data into Cube standard line format. Here we have traditional OD matrices, not versus, with TomTom OD matrices. The traditional OD matrices that come from surveys or census have some limitation, of course. They are usually sparse matrices, means that they contain many empty cells, not easy to allocate origin and destination, and mostly the day of cover for the analysis is limited, just limited to the campaign of survey. On the other hand, TomTom OD matrices have a wide territorial coverage, the possibility of choosing dates and time range, and the zoning system can be fully customizable to accommodate the zoning system of your model. Of course, TomTom OD matrices represent a sample of the universe. So it is necessary to expand this data, and a matrix estimation process can be useful in this sense. So we usually use the road vehicle traffic counts to expand this matrix. We use a static estimation process, which is an optimization process given by an equation. You will see it looks like a complex equation, but basically we can, beside from explain all the symbols, let's focus on what this term means. The first term represents the simulated volume. So what comes out from the modeling, from the assignment. Then we have a term referred to the prior matrix, in this case the TomTom OD matrix. And the last two terms represent the trip end, so the total productions and total attraction. This minimization problem is also constrained by lower and upper bounds. Next slide you will get with the slide will provide you a full list of what that symbol mean. So here is an example of Cube application used to expand TomTom OD matrix using Cube Analyst Drive. Cube Analyst Drive is a module, a program of within Cube Voyager, and basically you combine the three different components of matrix estimation, as to say the trip ends, the OD matrices, and the traffic counts, and you have the possibility of providing different weights to each of these elements. Of course, the so-called confidence. Of course, you give more confidence to the data that is considered the more reliable. So let's see how this process works. We start from a TomTom OD that we use as a prior matrix. From this matrix, we get the trip end, so the total productions and the total attraction. Sometimes these two elements can be provided from a different data set. If you have a more reliable data or a specific study has been done and you have different information. But on the other hand, you can generate automatically tripband from the TomTom metrics. These go over a matrix manipulation process, and where in addition to the prior metrics, we add confidence. So confidence is provided at OD level. So for each OD pair, we can use the same confidence for all the OD pairs, or based on our knowledge of certain movements, we can increase or decrease the confidence for certain movements. Also, the tripband comes with a confidence. In this case, because tripbands represent arrays, represent a vector of zonal attributes, the confidence is provided for each zone as a producer or as an attractor. Again, common value can be used, or ad hoc values for certain particular zones. This is on the right side. On the left side, we have the network itself. The network includes the count volumes, so they come as attributes of the network. For each count, a confidence is associated. So you see the three elements of confidence are in metrics, in tripband, and in counts. And the next information, the last information, is about which count screen line the count belongs to. So screen line is a way of grouping counts by families related to, for example, to identify cordons or to identify corridors, or in the sample of the picture, even geographic obstacles such a river can represent a screen line. It all depends on the geometry of the modeled area. So the network elements are prepared in a network manipulation process. So all this is done in Cube. And then the result is the network that is ready for the assignment. The highway assignment is then used. This highway assignment produced two different elements that are ICP file and SL file. These are like some working files that basically, the first one is the intercept file. It's based on the path that each of the takes, each of the route takes. And the second is a screen line, is basically a summary of all the counts with all the corresponding node of the links of the network and the associated confidence. These two elements, together with the tripband and the prior metrics, are combined as input to Analyst drive. Analyst drive, this module, runs metrics estimation. Of course, there is a possibility of setting up different parameters to control, for example, how much the metrics can be expanded or compressed, because the metrics estimation process works at OD level. So it tries to minimize the difference between observation and modeled and the metric and the demand. So there is a number of settings that can be provided in a control file, and the result is the expanded OD metrics. So we have expanded the original TomTom metrics to account for the universe, give out of the sample. Now this process is pictured as a circular process. This because usually we go through an iterative process in which we reassign the expand the matrix and go again through analyst drive, so through matrix estimation. This iterative process ensures that we reach at some point a convergence. So we are sure that the result of the matrix estimation is the best result, provided that it's not different from previous iteration. The difference with previous iteration become always smaller. We usually use root mean square error, RMSE, as a measure. Speed profile manipulation. Here we present a cube catalog, a cube application that look after the incorporation of speed profiles into a cube network and provide certain manipulation that I'm going to describe. So speed profile are deal with a parameter of the network, of the TomTom network, which is called speed SP free flow. This SP free flow is the average speed measured during the period of less congestion, usually at night. This doesn't have to be confused with the speed limit. This doesn't represent the speed limit. And to be honest, the speed free flow can be much higher than the actual speed limit. On the right, we see is that we have highlighted the link, a certain link, and we see the information that comes with the link: speed free flow, and then this 7 speed profile. Speed profile, each profile represents a day of the week. And this speed profile includes relevant information about the variation of speed across the time. What is this relevant information? So for each 5-minute interval within the day, so there are 288 time slots, 5-minute slot, the speed profile provide the value of relative speed, rel_sp, which is basically the speed percentage value in compared with the speed free flow. So basically, this is the equation. So for each 5-minute interval within the day and for each day of the week, we have we can calculate we can access to the actual speed by multiplying the speed free flow parameter for this relative speed. You see on the right an example of how this relative speed coefficient vary over the day. So 100 means that it equals speed free flow, and for example, this curve 22 as a minimum point at 77 means that at 8 a.m. The speed is for this curve is 77% of the speed free flow. So let's see, for example, how 2 links can have the same speed free flow, but they belong to different profile ID. So, for example, let's consider a Wednesday. So we will look at profile 4 on the network, 7:50 a.m. And the information that we got from the network is that the yellow link, the link with the yellow arrow, has a profile ID of 5. The purple one has profile ID of 22. This means that these are the curves for the 2 different links. If we look at 7:50 a.m., we see that the value of relative speed are completely different. The yellow one has a relative speed of 98.7, means that the speed at 7:50 a.m. for that link is almost 89 kilometers per hour. The purple one has a lower relative speed at that time, means that the speed is 70 kilometers per hour. So we can use this speed profile to calculate the average speed for a link over a certain time period. Don't be scared about the formula. Just we need to sum the various speeds using given the portion of the day of the time period that we want to cover. For example, if we consider an AM period of 3 hours between 7 and 10, we look at the speed profile tables, identifying the starting interval and the ending interval. We divide by 300 because 300 is because the time slot count the minutes before after midnight. So midnight is 0, midnight and 5 is 300, and so on. Another possible application is calculating the variation of total link running time over the day. This, for example, can be useful to check the overall time distribution of trips. So we look at each time slot and we consider the network model-wide. So what we can measure is how this total link time, so the link time is basically speed divided by distance. So the actual time to cross a link, you sum over all the networks or over a certain group of network. You may consider only major roads to ignore local road congestion, for example. It's up to you. And you basically you build a trend of congestion over the time of the day. Again, this is a tool that can be used in addition to other data that you have to confirm your for example, the choice of certain coefficients, peak hour coefficients, and so on. Later, speed profile can be also used for accessibility analysis. In this picture, we can see San Francisco, California, with at different times of the day, and as we can see, the accessibility to the this red point here vary across between the two pictures. So with speed profile, we can build for each time of the day, for certain time of the day, we can build accessibility maps. This functionality, the speed profile functionality, is usually used as when we have a large scale, whereas for small scales accessibility analysis, there is another tool from TomTom that is Luigi has already told, which is traffic stats. So depending on the scale, you may find it more useful using a speed profile or traffic stats. Thank you, and Alberto.
Thank you very much, Antonio and Luigi. Well, first of all, I'd like to thank all the participants. We understand that probably we should have scheduled a 3 hours or 4 hours seminar, given the number of questions and the subjects that have been raised in the chat box. Again, we will send answers. You just feel free to send us emails and contact us if you want to have information. Also, I want to highlight that both for TomTom and 𝗬𝗏, you can have a 30 days trial account or trial license. Just drop us an email and we will manage to give you access to the TomTom portal or to the 𝗬𝗏 software. Again, I see there are a lot of questions in the chat box, and I want to thank all the participants for raising them. I must admit that for some of them I don't even have answers yet. So we need to see and to get in touch with the developers to provide you with the right and accurate answers. One general comment is that again, well, some of you in the chat box are older than I am, but when I started like 24 years ago, just to have a good network was a nightmare. Now we have a very, very good data. And for instance, when we talk about Multinet and TomTom, just think about the opportunity of having straight away turn penalties, band movements. Imagine you have to build a model for a city, for a sustainable urban mobility plan. And you have the network, you have the characteristics, you have the details, you have the speed profiles, you have the free flow speed, you have the band movements. So in like 1 day, 2 days, you are ready to start with a very accurate network for your model, and this will save you a lot of time, not to mention traffic stats, origin destination matrices, all of this information. One general comment I might say, if I take out my commercial jacket, of course there are other sources of data. What I think it would be very, very nice and very, very good is to be able at a certain time to complete all of them, like mobile phone origin destination matrices together with GPS-based matrices. They are different. They cover different, they can be used for different purposes. They are not the same. They are not equal. So the advantage of these technologies, the advantage of these techniques is that they allow us as professionals to finally have access to an enormous amount of information that can enrich our models. Luigi briefly mentioned Junction Analytics. It's a brand new tool from TomTom. It's fantastic. In 10 minutes, you set up an analysis around the junction and you start having turning movements, estimation of flows, percentages of how the flows are spread in the micro network you are considering. And this is fantastic to calibrate and validate your microscopic models with Dynasim, with 𝗕𝗄, with 𝗕𝗄. Again, they can be used for they can be used with any software platform. So again, of course, we are cube people. That's where we come from. So forgive us for being so cube oriented, if you like, and we are TomTom people. But that's the scope of the seminar. The scope of the seminar is to show you how we use these techniques as consultants, as professionals, and to let you know that if you want to have information about that and if you want to try, just send us an email and just feel free to ask, and we will be back to you with specific presentations if you like, or with any or providing you with these trial accounts I mentioned. Okay, so I see that questions are popping up, and so just send us emails, okay? Because it's basically time to go. And I'm seeing the comments here with Richard and Tom, Luke and friends that really, we know each other since a long time. And I'm glad this seminar generated so much interest. As Luigi said, we have created this little LinkedIn group. I don't know if Antonio, if you can go back to the slide. And again, it can be, if you like, just an area where we can talk together and discuss together about how to use these technologies to make our profession easier, better, more efficient, to improve the quality of our work. And in general terms, I really trust that what we do as transport planners is something that helps society, helps our cities, helps our communities. And if we can do things better with better data, I think it's our duty really to look for these new sources of data and use them in a very efficient way, so to make our models, our studies more accurate, better, and so give better results to our cities. So I think it's time to go. Again, just feel free to send us emails. Also, let me thank Douglas from TomTom, who took the time to answer directly some of the questions related to TomTom. And again, we will back to you. As I said at the beginning, the presentation has been recorded, so we will send links to download the presentation in PDF format and download the recording. Thanks again. Thanks Luigi. Thanks Antonio. And goodbye, everybody.
Thank you very much. Bye.
Bye. Bye. Bye.
Bye, everyone. Thank you.